Have you ever used a compass and noticed the needle pointing north? Well, what if I told you that the north it's pointing to is on the move, and it's moving faster than ever before? This isn't science fiction. It's a real-life planetary mystery unfolding right beneath our feet. We're talking about the Earth's magnetic field, the invisible shield that protects us from harmful solar radiation, and its North Pole is making a run for it. So, what's really happening? Is this a sign of something catastrophic or just a normal part of our planet's life cycle? Today we're diving deep into the science behind the wandering pole, separating fact from fear, and exploring what this mysterious shift really means for us and for the future of our planet. Stick around because the story of our magnetic field is more dynamic and fascinating than you might imagine. Let's rewind the clock a bit. The concept of a magnetic North Pole isn't new. For centuries, sailors and explorers have relied on it to navigate the globe. But it was in the 1830s that scientists first pinpointed its location in the Canadian Arctic. For the next century and a half, the magnetic North Pole behaved itself, wandering only slightly. It moved at a leisurely pace of about 9 to 15 kilometers per year. Think of it as a slow, predictable stroll. Explorers could track it, map it, and update their charts accordingly. It was a reliable, albeit slightly shifty landmark. But then, something changed. Starting around the 1990s, the pole decided to pick up the pace. Its leisurely stroll turned into a sprint. The speed ramped up dramatically, reaching an astonishing 55 kilometers per year. This wasn't just a slight deviation, it was a fundamental change in behavior. And it wasn't just moving faster, it was moving with a purpose, on a direct path from its long-time home in Canada, across the Arctic Ocean, and heading straight for Siberia. This acceleration has scientists buzzing. The World Magnetic Model, which is the standard model used for navigation by everything from your smartphone's GPS to military and aviation systems, had to be updated ahead of schedule in 2019 because the pole was moving so fast that the old model was becoming inaccurate. Imagine trying to hit a moving target that suddenly starts zigzagging at high speed. That's the challenge geophysicists are facing right now. So what's causing this sudden dash? The answer lies deep within the Earth. Our planet's magnetic field is generated by the movement of molten iron in the outer core, about 3,000 kilometers below the surface. You can think of it as a giant, churning, electrically conducting ocean of liquid metal. This process is called a geodynamo. It's incredibly complex and chaotic, like a planetary-scale weather system. Recent studies suggest that the rapid shift is being driven by a sort of tug-of-war between two large magnetic blobs, or lobes, of molten material deep under Canada and Siberia. For a long time, the Canadian lobe had a stronger pull, keeping the magnetic pole tethered to its Arctic home. But lately, it seems the Canadian lobe has weakened, and the Siberian lobe is gaining strength, pulling the pole across the Arctic at an unprecedented rate. It's like two massive magnetic forces are battling for control, and right now Siberia is winning. This might sound alarming, but is it really something new for our planet? To answer that, we need to look even further back in time, not just hundreds, but millions of years. This is where paleomagnetism comes in. It's like geological forensics. Scientists can study ancient rocks, particularly volcanic rocks, which contain a record of the Earth's magnetic field at the time they cooled and solidified. When lava erupts, tiny magnetic minerals within it act like microscopic compass needles. As the lava cools, these minerals align with the planet's magnetic field at that moment and get locked into place. By analyzing these ancient rocks from different eras and locations, scientists can reconstruct the history of our planet's magnetic field. And what do these geological whispers tell us? They tell us that our magnetic field is anything but stable. The rock record shows that the magnetic poles have wandered all over the globe throughout Earth's history. More dramatically, they've completely flipped. That's right, a full reversal, where the magnetic North Pole becomes the magnetic South Pole and vice versa. These magnetic reversals aren't a rare occurrence. Evidence suggests they've happened hundreds of times over the last few 100 million years. The last major reversal happened about 780,000 years ago. So, we're actually a bit overdue for one, geologically speaking. These reversals don't happen overnight. The process is thought to take several thousand years, during which the magnetic field can become much weaker and more complex, with multiple north and south poles popping up in different places across the globe. So, could this current rapid drift toward Siberia be the beginning of a new magnetic reversal? That's the billion-dollar question. Some scientists believe it's a possibility. The weakening of the magnetic field, which has been observed over the last couple of centuries, combined with this accelerated pole drift, are consistent with some models of how reversals begin. However, not everyone is convinced. Other experts point out that the pole has made rapid excursions in the past without leading to a full flip. It might just be a wobble, a significant deviation that eventually corrects itself, with the pole perhaps slowing down or even reversing its course back towards Canada. The geodynamo in the Earth's core is so chaotic and unpredictable that forecasting its long-term behavior is incredibly difficult. We simply don't have enough data to say for certain which way it will go. But let's entertain the idea for a moment. What would happen if the magnetic field did flip? The most significant consequence would be the weakening of our planetary shield. During the transition period of a reversal, the magnetic field's strength could drop to as low as 10% of its current value. This would leave us and our technology more vulnerable to solar winds and cosmic rays. Solar winds are streams of charged particles constantly flowing from the sun. Our magnetic field deflects most of them. Without that strong shield, these particles could bombard our atmosphere, potentially damaging satellites, disrupting power grids, and causing widespread blackouts. The beautiful auroras, the northern and southern lights, which are usually confined to the polar regions, could be seen all over the globe as charged particles interact with the atmosphere at lower latitudes. For wildlife, the effects could also be profound. Many species, from birds and sea turtles to bees and salmon, use the Earth's magnetic field for navigation during their long migrations. A chaotic multipolar magnetic field could be incredibly disorienting for them, like trying to navigate with a compass that's spinning wildly. It could lead to them getting lost, impacting their breeding and survival. We've seen instances where whale strandings have been linked to local magnetic anomalies, so a global-scale disruption could be a major challenge for the animal kingdom. Now, before you start building an underground bunker, it's crucial to put this into perspective. There is no evidence in the geological or fossil record to suggest that past magnetic field reversals have caused mass extinctions or catastrophic events for life on Earth. Life has weathered hundreds of these flips and has continued to thrive. Our atmosphere also provides a significant layer of protection from radiation, even with a weaker magnetic field. The biggest challenge would likely be to our technological infrastructure. We are far more reliant on electricity and satellite technology than any society in Earth's history. A reversal would force us to adapt, to harden our power grids and build more resilient satellites. But again, this is a process that would unfold over thousands of years, not overnight. It would give us generations to prepare and engineer solutions. So, returning to our original question, what's really happening with the Earth's magnetic field? The North Magnetic Pole is indeed on a rapid journey towards Siberia, driven by dynamic, churning processes deep within the Earth's core. This drift is part of a long history of magnetic change, including dramatic reversals that have happened many times in our planet's past. While it's a fascinating and scientifically important phenomenon, it's not a doomsday event. The current shift serves as a powerful reminder that we live on a dynamic, ever-changing planet. The ground beneath our feet and the invisible forces around us are in constant motion. It highlights the incredible work of scientists who monitor these changes, update our navigation models, and strive to understand the deep inner workings of our world. So the next time you use your phone's map, take a moment to appreciate the complex science that makes it work, and the incredible churning planetary engine that sets the direction. The pole may be wandering, but our scientific curiosity is what will keep us on the right path. Thanks for watching. If you found this journey into the Earth's core as fascinating as I did, be sure to hit that like button and subscribe for more deep dives into the science that shapes our world. And let me know in the comments, do you think this is the start of a reversal or just a temporary excursion? I'd love to hear your thoughts. See you in the next video.